起来一下，要躺在床看的。
Okay, we're recording. I'm starting the class now. Let's see, I'm sharing and let's see. This is what I want to share. Yes, but here we go. Okay, so the goal of today's class is to prepare everybody for the midterm, which is going to be on Thursday. And hopefully everybody's gone this midterm review. Some of you might need to mute yourself. I'm getting some noises. Here's how the exam will work. So the exam will show up just like a regular Canvas assignment. It'll probably pop up on your Canvas. You'll be able to see it probably at around 11:55, 56, something like that. A few minutes before noon, the exam will pop up and you can start on it right away. The exam ends at 1:20. Now, the class ends at 1:15, but I'm giving you this extra 5 minutes because what you're going to do is you're going to create a zip file containing all of your source code that you've written in any star UML file that you've created. And you're going to upload that to Canvas. And of course, you have access to the internet, your computers and everything during the exam, but I do not want any, I don't want any group efforts here. So if I see exams that look suspicious in any way, I won't grade them, and that person's going to get 0 for the exam. I'm planning about maybe 2 to 4 problems on the exam, and yeah, so that's sort of a general description of the exam. Here's some, I think, useful tips for the exam. So, I use Eclipse, and I have in Eclipse a project called MVC Apps. Okay? And in here, I've got these packages. I've got a package called MVC. That's my MVC framework. I've got Stoplight. Got BrickCAD, and I've got Turtle, the Turtle graphics assignment. I've got like a whole bunch of things in there. These are all working applications, and I know how all of the code in these applications work. Okay, and so what I would do if I were taking the midterm is before the midterm, I would create a new package. I'll call it Midterm. Okay, that's inside of this MVC Apps project. Okay, so I've got a midterm in there, and probably there's going to be, very probably there's going to be a problem in the midterm that says customize MVC, right? A customization. We have a sample problem like that coming up in a minute, right? And I'll tell you this, I'm not out to throw you any curveballs. This thing will probably be, like some baby version of Turtle Graphics or something like that. You'll have a control panel on the left with a couple of buttons on it. You'll have a view on the right. Okay, and so I think that what you'll be able to do is to quickly copy and paste code from these other customizations and just tweak the code a little bit, and get something that's going to be running. The other thing that I find useful is that I've become very adept at using that source menu in Eclipse, and I don't know what the equivalent thing is in IntelliJ. Somebody asked for a demonstration of this in the last section. Maybe we can do that again, but you can quickly generate constructors, getters, setters, delegators, and overrides from this menu. So it saves, seems like a lot of time. You can just sort of jet through these things. So at the end, let's say that I've asked you to customize, create an MVC customization. Okay, and then let's say there was another problem where I asked you to create a class diagram. Well, let's go to the class diagram. Let's skip this, go to this paragraph next. I would also, before the exam starts, I would create a UML project called Midterm. I would import my Java and MVC fragments into it. Now, just yesterday morning, I updated those things, so you can download the zip file from the MVC notes, lecture notes at the bottom of that page. I would load those fragments into the project. I'd save the project to a file called maybe midterm.mdj. And let's say problem 2 on the exam says, draw a UML class diagram, blah, blah, blah. Okay, well, you would create a package in the midterm project called problem 2, and then add whatever diagrams I had asked for into that. So then at the end of the exam, you might have all of these .java files from your project, from your MVC customization. And you're going to have this midterm2.mdj file here, right? And so you're going to zip all of that together and upload that to Canvas. Okay, now. There is in Eclipse, and I'm sure IntelliJ too, there's like an export menu. And you can export to the file system your source code. And this is useful if you don't know where Eclipse hides your source code. So wherever you've installed Eclipse, if you look under there, there'll be like workspaces, and you would be able to root through the file system to find where it's putting your source code. But if you don't want to do that, you can export it to your desktop after you've written all of it. So you'll see it all there on your desktop, easy to get to. Maybe a midterm.mdj is there too, or maybe you have a special folder, midterm. We're going to keep all of this stuff, and just so it's really easy to zip it together and upload it to Canvas. You will be in trouble if like the midterm, the time of the midterm is the first time that you've like done this sort of thing. So, make sure that, you know how to get a hold of your source code from inside of Canvas or IntelliJ and zip it together. And I will want just the source code. I don't want, don't give me the entire project. And I will want your source code to include your MVC framework in it as well. Okay, so I think those are all really good tips. Those are things that you can do right now. Here's the review. Let me see how we're doing here. Could you please record this session? I think it is recording now. Let me just double check on that. Yeah, there's a little button that says recording. So I think I am recording it. By the way, I mentioned in my post yesterday, I had 2 worrisome crashes. Everything just froze up. I rebooted my router, which seemed to fix the problem. I don't know, kind of scary. That happens today. Give me about 5 minutes to see if I can come back on the screen. But if I don't, then you'll just have to go through all of the review yourself. Let's cross that bridge when we get to it. Here's like a review of all of the stuff that we talked about. This is a review of class diagrams. I think I'm not going to cover use case diagrams on the exam, just class diagrams. You should be able to translate a text description of a domain into a class diagram. You should be able to incorporate the patterns we discussed into your class diagram. And you got to know what all of the arrows mean in UML. There are like, I think, 3 different kinds of arrows: generalization, association, and realization. So those are the three arrows. Don't get them mixed up. This is explaining about object-oriented programming and some of the main concepts in object-oriented programming. And and you can see these concepts. Let's go through the stack machine problem together. Where is stack machine? Let's see. You should be seeing my. Let's see, is it under, yeah, here it is, stack machine. So here is my, here's my stack machine. And it's got in it a stack, which is static. So I don't like this design at all, but it's got in it a stack, and it's got an execute, which takes a program as an input, clears the stack, and then it executes the program. So let's look at the stack class first of all. So a couple of concepts here that you need to know. The stack is generic class. A generic class or an interface means that it has a type parameter in it. Okay, in it it's storing the elements in a list. So there's lists and sets in Java. You should know when to use one and not the other. I'm using list here because order is important in a stack. Set, we'd use that if like the order wasn't important. Here I'm pushing an element of type T onto the stack, just adding it to the end. Here top, you're asking what's on top of the stack, so I'm returning something of type T. But if the stack is empty, I'm going to throw an empty stack exception. Okay, so you need to know how to throw exceptions. Pop, same thing. If the stack is empty, you get an empty stack exception. Now what I've done here is I've got like a hierarchy of all of the different kinds of exceptions that stack machines might throw. So I introduced this base class, which extends exception, an empty stack, extend stack machine exception, short stack, and divide by 0. So that's very commonly done on a software project. You have a hierarchy of all of the different things that can go wrong. Now you also need to know how to catch exceptions. So here, when I'm executing the program, any of these exceptions could be thrown. And so look at this, I have a whole list, a gauntlet of different catch blocks here. If you divide by 0, control's gonna go here. If you have an empty stack, control's gonna go here. If it's something more general, just a stack machine exception, control goes here. And then most generally, just an exception, control goes here. Now, I'm doing the same thing in each of these blocks, but it opens it up for the possibility that some customer of ours could have different way of dealing with divide by 0 than they do with, empty stack. And so we've got like a place to, to put those handlers. The finally block here gets executed if an exception was thrown or not. And here I'm just going to print out the stack. So those are two important object-oriented concepts, catching and throwing exceptions and generic classes. Let's look at my command. So this is something that I think is that I like. Here I have this hierarchy of commands. The top of the hierarchy, it's just an interface, and I'm stating here a command is something that knows how to execute itself, but it might throw some kind of a stack machine exception. And then here's push command, pop command. Here's add command. This is like too complicated. This is too fancy probably for a midterm scenario, but here, I might throw an empty stack exception, short stack exception. I go to the stack machine. Now I'm using the name of the class here. The stack was static. This saves me from a pointer there, although it's actually kind of a lousy design. And I'm getting the top of the stack. That might throw an exception, an empty stack exception, which means that execute implicitly throws an empty stack exception. Okay, and now I'm going to remove it from the top of the stack. And then here, I'm going to ask what's on top of the stack again. That might throw an empty stack exception if there is only one thing on the stack. I catch the empty stack exception, I push arg1 back on the stack, and now I throw a short stack exception. So these are all kind of tricks that you can do with exceptions. Now let's look at program. So program is a list of commands. And again, it's a list because the order of commands in a program is certainly important. Okay, here's adding a command to the list. This is an example of a delegator method. You can get Eclipse to generate those automatically for you. So this list, I don't want to like just say get commands and just hand over this entire list of commands, because there's all kinds of havoc that somebody could wreak on this list if I just let them have it. Instead, I say, well, what are the list commands? There's a long list, and which one of those do I want to make available to my customers? And add was the only one. So add calls commands.add. And since commands is private, that's all my customers get to do. Now, here's the other important thing, lesson here, execute. Okay, so I'm going to iterate through the list of commands and execute each command. Okay, this is a classic example of what I call like a dumb method. It's dumb because it doesn't know about the different kinds of commands. It doesn't know that there are add commands and multiply commands and maybe some future kind of command that we haven't thought of yet. Dumb is good in object-oriented programming. We call that a form of polymorphism, okay? Because it's dumb, if we add more commands in the future to our system here, this code does not need to be updated because it never really knew what kind of commands there were in the first place. It's just whatever the next command is, whether this is an add command or a multiply command, it's the commands, it's the data that decides what code to be executed. This is sometimes called data-driven programming. Data decides the flow of control, not the programmer. You're lucky to have me as your teacher because, you know, I actually programmed in the days before object-oriented programming. Back in my day, we would have to say, well, if the command was an add command, then do this. Else if it's a multiply command, do this. Else if, else if, else if. And each time somebody says, hey, I've got a great new idea for a new kind of command, you know, we would sigh because, well, we're going to have to modify this code. We have to add a new else if clause in there, and possibly dozens or even hundreds of other places in our source code that have to be updated. So you're really opening yourself up for errors there. Generics are also sometimes referred to as a kind of polymorphism, generic polymorphism. Here when I'm defining stack of T, I'm actually defining many different classes, one for each value of T. The same thing with command. When I define command, I'm actually defining many classes here, one for each subclass of command. Okay, let's see what we are doing. So somebody is asking, want the MVC package and the midterm package and midterm.mdj as a zip. Yes, yes, so make sure that you know how to do that. Okay, let's go back to the midterm review. So I've given you all of the source code for that, didn't I? Oh, I did it on the solutions for the homework, right? If you go to demos, you should know this. You know, here are the solutions for homework number 2, and I think, yeah. So all of that stack stuff. Here's all of the designs for it. Here's the implementation for it. So I've given you all of that stuff. Patterns covered. Okay, so here are the major patterns that you're supposed to know. And you can go, see, you go to lectures, design patterns. So here's a quick synopsis of all of the patterns that we covered. The first 2, actor, role, and types as objects, those are usually used in domain modeling. There's the adapter pattern, publisher, subscriber, composite, strategy, utility, singleton, and yeah, we did use singleton somewhere, but I can't think where. Oh, you know what? This looks, let me just reload this. This looks old and funky. Sorry about this. This does not look, I wonder if I forgot. Let me, I'll re-upload that page a little bit later. But let's go through example strategy pattern. Let's look at the Tournament of Doom. So this is one of the examples we did in class. Remember this setup here? We have like a gladiator class, and he has a method in here, fight, and it takes an argument, the opponent, which is another gladiator that he's fighting. Okay, and inside of fights, the algorithm here depends on the kind of weapon that he's using. So he has this weapon. So fight the opponent probably calls strike opponent several different times. Now, this diagram doesn't show it, but weapon would typically be an interface or an abstract class. And then sword, whip, and wand, you know, are subclasses of this. And so we can think of sword, whip, and wand as different algorithms for fight. And so the cool thing about this pattern is in the middle of a battle, the gladiator can set down his sword and pick up a whip instead. And now suddenly when he's fighting his opponent, we're seeing a completely different kind of behavior, seeing whipping behavior instead of you know, stabbing behavior. And so this ability to change algorithms. On the project that you're doing, Prisoner's Dilemma, we use a strategy pattern there too. Here, instead of gladiator, we would have prisoner. And I think he has a method called cooperate, which returns true, I will cooperate, or false, I'm going to cheat. And he has like a strategy for deciding which way he's going to go. So this would be cooperation strategy, just an interface with maybe a choose method in it. And then you would have, for example, always cooperate. So choose always returns true. Always cheat. Choose always returns false. Random strategy where choose just randomly picks between true and false each time you call it. And then I think there's a 4th strategy called tit for tat, which you do to your current opponent whatever the last guy did to you. So also another place where we see this is in J component. So J component, so here gladiators, J component, and there's a method for adding a child, adding like another component to it. And then here we have a layout strategy with grid layout, flow layout, border layout. Those are the different strategies for deciding where the component would get placed. let's look at another example, Virtual Studios, another example that we did. Okay, here is the design for Virtual Studio. This is meant to imitate graphics in Java. It has that graphics class that gets passed in, graphics object that gets passed into Paint component, and it has a and it's basically the same as Canvas. It's like a canvas, and on that canvas, it's populated with a bunch of shapes. Ellipses, rectangles, polygons, and so forth. So here, our canvas has a bunch of shapes in it. And I have two kinds of shapes, simple shapes and group shapes. A group shape allows us to group together a bunch of shapes as a single shape and manipulate them, translate them, and draw them as a single shape. So shape is an interface. Group, this is the realization arrow, realizes or implements shape. And group has a bunch of subshapes, 0 or more subshapes. Those shapes could also be group shapes. So, groups within groups, okay? And then simple shape, here we have polygon, label, and circle adapter are different kinds of simple shapes. So a shape, like a group shape, would be a tree-like structure. The parent nodes will be groups and the leaf nodes will be simple shapes. So this is the composite design pattern. Another place where you've seen this is with J panels, right? A J panel, I think it's also true for a J component, has components inside of it. And those components could be other panels, so panels within panels within panels. And we did that so that different regions could have different layout strategies. So Java combines together. Java was back in the 90s, they were very big into design patterns. So it was like the hot, design patterns just really got popular in software engineering in the 90s. So it was very hot back then. So they really bought into it. So they're using the strategy pattern and the composite pattern in their panel library. Another problem we face, so here we have our simple shapes. This is an abstract class. I made it abstract because all of the simple shapes have colors associated with them. So rather than make each one of these classes have a color field, I just put it into, I let them inherit it. But the problem is that, our boss came to us and said, hey, we have this circle class from some older version of this. For some reason, we want you to reuse it. Well, unfortunately, the circle class was created before, we had this hierarchy of simple shapes. So he doesn't know anything about simple shape. And, and so what I do is I create a circle adapter. Now, this is the association arrow. So a circle adapter is associated with one circle. He refers to it as his adaptee. Sometimes I call this the has a arrow. Circle adapter has a circle. And then he extends simple shape. And I'm going to make a little note to myself. I don't have the code for circle adapter. So I'll try to get that code out to you for that. But basically, he implements draw and translate by calling adaptee.draw and adaptee.translate, or maybe they have slightly different names. That's fine too. So that's the adapter pattern. We're taking a legacy class and we're integrating it into like some hierarchy. Publisher subscriber, we use that all over the place. There are two important examples of publisher subscriber that you need to know. One is, so the general idea is a publisher fires events, and then subscribers are notified of the events. So the publisher doesn't need to know the identity of these subscribers. A subscriber is just subscribed to the publisher. Okay, well, Couple of places where we see that. One is in Javabeans. So a Javabean fires property change events, and there are property change listeners that react to them. And the example we see, the model is a Javabean. Okay, every time you modify the data inside of the model, it fires property change event. And then the views and the app panel are the subscribers. They're notified when the properties have changed, and they can go find out what's changed, and they can update themselves appropriately. The other place where we saw this is like the buttons and the menu items. Those guys are publishers. You click a button, it fires an action event. And the subscribers are called action listeners in that context. And so app panel is the action listener for all of the menu items and for all of the buttons. So it gets notified when there are any changes, you know, and then this is usually like some user input. You push a button, you want to move, have the turtle move. So we can go to the model and, you know, ask the turtle to move. And that, of course, then notifies, you know, all of the views, say the turtle's moved, and they can update themselves. Command processor, you know, we here what we've done is we represent commands. So traditionally, a command was just a string, but command processor, we represent commands as objects. So this is the clear command from Turtle Graphics. It calls it initializes model in the command class. And then down here, execute, casts the model as a turtle and calls, you know, whatever the appropriate turtle method is. Abstract factory, there, this is getting used. You know how to build the assembly, but you don't know how to build the components. So you say, you pass in a factory, an abstract factory to your constructor. The abstract factory has a bunch of methods that make the components. Those are sometimes called virtual constructors or factory methods. A factory method, you know, like make model, creates, you know, some kind of a model. So it uses that to create the model, the commands, the title, and so forth in the MVC framework. And then finally, model view controller. This is an architectural pattern. So the model is where the application data and logic is stored. The view is some sort of representation of some of that data in there. And then the controller is where the use cases are implemented. In our version in MVC, the controller is replaced by the different commands. So I did a brick CAD for you. There was like a video out there. You should go through that example. The model was the brick. It's, the data was the height, width, and length of the brick. The logic was, you know, methods for changing height, width, and length. The views, we had side, top, and front view. Okay, and then the controllers, those were the commands for changing the height, changing width, and changing length. The important thing about MVC to remember, the views and controllers know about the model, but not the reverse. The arrows only go one way in that architecture. The idea is that you should be able to change the views and controllers without having to make any modification to the model. Okay. Let's see how we're doing. Okay. I am assuming that everybody's still there. So are you still with me? And there, I haven't stopped. Yep. Okay. Good. Thank you, Stephen. Okay. Here are the sample questions. Most of them I've got Most of them I've got, the solutions here for you, or this problem 2, I don't have a solution. I'll post one of those solutions for you. Problem 3 as well. But before, the internet comes crashing down, I want to go through the ones that are most likely to see on the exam, which is problem 5, 4, and 2, I think are the ones that are the most similar to what I'm contemplating for the exam. Problem 5 is Casino Royale. This is an MVC customization. This particular application is a bit harder than what I probably planned for the midterm. So I'm getting a question. This one, would you mind upload the star UML file for one of the MVC examples later for our reference? Let's see. I could do that, certainly. I don't mind doing that. I just want to remind you that that you have like the complete MVC, this MVC package that I posted out there, so you can see the UML, complete UML design for my MVC. It does, Stephen does bring up like a good point here. It's possible that your MVC implementation that you did for, let's see, Turtle graphics, let's say, is different from mine. And so then that brings up the question of, well, which MVC framework should you use for the midterm, and which MVC framework should you use for the SimStation project that's due? And the way I see it, you have two choices here. If you are competent in your implementation of MVC, if your implementation of MVC uses the patterns that I use, so I use, for example, the command processor pattern, my MVC is cool because it implements all of the logic for all three menus, file, edit, and help, are all built into the framework. So different customizations don't have to do that work. All you have to do really to customize it is make that, implement the factory abstract, the app factory interface, which has some work around it that you have to do. But if you are doing that, then you could go ahead and use your MVC framework. But if you don't like your MVC framework, and I've been reluctant to share code with you because on the MVC itself, just because, that's, I want you to figure that out yourself, rather than just, copy me. Well, there is this Mvc UML fragment that I updated yesterday morning. You could download that, and you could implement that or compare, that design with your implementation. So, and I've given you big chunks of MVC code as well. So either one of those would be a way to, approach it. But I will do, and I've given you several examples of UML examples of customizing MVC. I can point you toward them a little bit later. Aisha's asking if we have enough time to complete the midterm. So I will tell you this. This is not my first time doing UML. I'm sorry. Sorry to forget. This is not my first time delivering midterms or exams on Canvas. So, I've been using Canvas to do midterms, since we started adopting Canvas. And so I'm well experienced at this, and I've often thought, giving these midterms on Canvas. Why do I have to sit in the room here and watch these people, take the exam? I could be, sitting at home, in Santa Cruz with my cats, which is exactly what I'm doing now. So I'm well practiced at designing midterms that can be done in the allotted time, assuming that you've studied and you have practiced doing similar problems and so forth. I mean, if you're just coming to, to all of this material, you haven't been doing the work, if you're not, up to speed, then you probably won't finish it on time. But generally, 90% of the people do finish my midterms on time. Somebody else is asking if you have to do it in the scheduled time. Yes, so I won't accept any late midterms. All right, let's go on to Casino Royale. So here's what it looks like. And again, this is a bit more complicated than what I plan to give you. So this is an MVC application. Here's the way it works. You click this roll button here, and it rolls these these things are supposed to be dice. It rolls these two dice. It generates two random numbers between 1 and 6. Here, this dice has 4, and this dice has 3. 7 is the total. The rules for Casino Royale, which is a game I made up, is if you get a 7, that's a win. If you get a 3, that's a loss. So right now I've got 1 win, probably from this roll, and I haven't lost yet. File as save as the usual things on it, and that works. Help as help and about on it, that works. Edit, there's only one edit command here, which is roll, which does the same thing as this button. That, by the way, is one of the advantages of the command processor pattern. Oftentimes an application will give the user several different ways to do something. You can use the menus, you can use a button or a hotkey combination, but they all generate the same kind of command. Here's my design. So Casino extends model. So this is my model. I always begin with your model class. In here, my data, my application data is die 1, die 2. These are the integers, from the roll of the die, number of wins, number of losses. My application logic is this roll method for rolling the dice. And then here is my view design. So that would be the second thing I would do, is to implement the view. Now here, I don't want you to, so Casino View extends view, and it's got paint component in it. And I don't want you to freak out. This is way too complicated for the midterm. But I'm using some fancy graphics. So I also have a class for representing each dice. So I've got my Casino View has 2 dice in it, die 1 and die 2. And it's a component with a paint component and a value. This is the total sum of the, this is what was on the dice, what number was chosen for the dice, a random number between 1 and 6. And that tells you, paint component, how many dots are red and how many are black. And then each dice has 6 dots on it, and the dot has a color, red or black, whatever. And then paint component just draws a picture of a dot, and it has 6 of these dots on it. So this part here, yes, is way too complicated for the midterm. Let's look at the implementation. Here. Here's my MVC apps, and here's all of the packages, all of the code that I've been working on for for you. And I called it craps originally, which then I thought, oh, well, maybe somebody would be offended by that. Craps, so I changed it to casino for the midterm. So casino is still the model class, so it extends model. Right, here's the data, the die 1, die 2, the losses, and here's the logic. So die 1, so in utilities, I have a random number generator. So make sure you download my utilities class, got that random number generator in it. And I generate a random number between 0 and 6, 0 and 5. This will be less than 6. And I add 1 to it, so now it's a random number between 1 and 6. So I do that twice, okay? I calculate the sum of these two. If the sum is 3, I increment losses up here. If the sum is 7, I increment wins here. And then here's the important part. I've changed my data. I've changed die 1, die 2, wins and losses. So I call changed, which is from the model class. Changed in my model class fires a property changed event. And then the views and the panel pick that up and they can update themselves. Next, casino view. So I don't want to get, can be a little, this is way too much code for the midterm, but a view has 2 dice in it, die 1 and die 2, dice. And then here's paint component. Paint component casts the model as a casino. It gets the value from the 2 die, okay? And then die 1, it sets its value to die 1 value, die 2, it sets its value to die 2 value. I thought, well, probably need to call their paint component methods, but no, that's going to happen automatically because they're inside of it up here. So their paint components will get called. Here's my die class. It's a J component, okay? And it has an array of 6 dots in it. And paint component, it goes through this array. If I is less than value, it sets the color of dot I to red. Otherwise, the color of dot I is set to whatever the default color is for this graphical context. And then here is a die. His paint component sets his color. It can be red or black. And then it just draws like a filled in oval and sets the color back again. So yes, too much code for the midterm. I'm aware of that. So after I do the view, I next do the panel. Okay, so my panel calls the super constructor, and it grabs this casino. Here's the layout. Now, your layout will be similar to this. You're going to probably have a button panel and a view panel. So I'm choosing, setting the layout to a grid layout with 2 panels. Here I'm creating the button panel. And then here I'm adding those text fields. So I have these text fields, roll, losses, and wins here. And let's just look at the last one. Here's like the roll button. This is a new J button with the label roll in it. The name here is important. This next is important. I'm going to add myself as the action listener. That's because really it's app panel. My app panel listens for these things. And so, you know, I need to be informed, you know, when somebody clicks the roll button. And then I put the roll button in some panel P, and I add the panel P to the button panel. Here I'm creating a casino view. Now I'm adding the button panel and adding the view. Now here's the thing. Probably the panel on the app panel for the midterm, the question in the midterm, will probably be very similar to the panel for Turtle Graphics. It's going to have like a bunch of buttons. I don't think I'm going to throw text fields at you because they add extra complexity to it. So you'll have a bunch of buttons, and you can just borrow. I would just go to my, let's see, what did I say? Turtle panel. Right? I would just grab all of this code, scroll down, and I would just paste it into your constructor. I'd also grab the main, I just grab all of this stuff and put it into your constructor for whatever the midterm is going to be. Gosh, you could almost like do this ahead of time, since you don't know what the application is going to be called, but you know, if you want to call it midterm panel, that's fine with me. So midterm panel looks just like turtle panel, right? And then you can, when it comes time, you know, maybe it doesn't have this many buttons on it. So you get rid of a few of these buttons, you change the names of the buttons and so forth, and boom, you know, in 15 seconds, you've got like a decent looking user interface, right? So it'll be very similar to this. You know, here instead of a turtle panel, will be a midterm panel with a new midterm factory. Gosh, this thing's getting easier and easier all the time. Okay, let's see. So we've done the panel, we've done the view. Oh, the commands. Commands are super easy to do. Here we have roll command, extends command, and here's like the constructor for this. I'll check, and then here's execute. And it'll begin the same. You're going to take the model inherited from command. You're going to cast it to whatever the model is. And then you're going to call, you know, whatever the relevant method is. And that will fire a property changed event, which will inform the views that, you know, something has happened. Check this out. I'm going to get rid of this constructor. Instead, I'm going to go to my source menu, generate constructor from superclass. Superclass is command, boom, and there it is. Right? Important here because we've got to pass the model up into the command class. It's, you know, maintaining that reference to a model. So that source menu's very nice. And then finally, the casino factory. This is something I did for my earlier section to get rid of all of this. So you need like a factory. So here I've got casino factory to implements app factory. I go to my source menu, override implement methods. So these methods, yes, those methods, and boom, it's done. Okay, now, you know, again, let's look at the turtle factory. So, you know, a lot of this stuff is just cut and paste, right? You know, here, okay, that's, you know, I mean, gosh, I wonder if you could even do this in advance. Oops. Right, so about, bam, I'm going to put that in here, you know, and instead, turtle graphics, it will be called casino, whatever text that you want to have in here. And I would do that for all of the methods in the turtle factory, which probably is out there somewhere, you know, and I would just tweak these methods, and I'll give you like a little hint. I probably, when I grade this thing, I'm probably not going to look at what you have under your help menu. You know, it takes too much time. I will look at your title here. So, you know, for the title, you know, you might want to like put something reasonable. Right, but I mean, it's really easy to, here's your model, you have to return a new casino. Yeah, let's see. You're not seeing my screen? Oh God, I'm not sharing this with you. Sorry. I'm so sorry. Hang on. So sorry about that. You start over again. So I am, I'm pretending like I've got this casino problem on the midterm, right? And here for the roll command, for example, here's a roll command extends command. So I'm going to get rid of all of this stuff here. Okay, and I go to the source menu and I would generate constructor from superclass. Boom, there's the constructor. And then source menu, override implement methods, the execute method. Okay, there's the execute method. And then the first line is always the same sort of thing. Take your inherited model and cast it to whatever your actual model is called. And then you call like whatever the method is that needs to be called. Here I'm calling roll fires an update, property update event, which gets picked up by the views in the panel. They can now update themselves. Here's a casino factory. I'll show you what I did there. All of this stuff out. Casino factory implements app factory. So I go to the source menu, override implement methods. Okay, boom. Okay, then what I would do is, and then what I was suggesting is, gosh, you could, why don't you build an application before the midterm, an MVC customization called Midterm, right? I don't really care what it's called, right? Called Midterm, and see how much of the midterm, the MVC question and the midterm, how much of that can you build without knowing what it is? So for example, here's Turtle Factory. Most of this code, like here is get help. Okay, let's do get commands. It's a little more significant. So here are the code for edit commands. I'm going to paste it in here. Well, I have a roll command. Returns a new roll command. Okay, and then I don't have any of this other stuff. I'm going to get rid of it. Right, and boom, I'm done with that. So you could, if you have like a properly functioning, turtle graphics, you could probably copy, a good, 80% of that code. And the same thing with the, with the turtle panel, right? Your panel, midterm panel, is going to look exactly like this code, okay? Except here it'll be midterm panel and midterm factory. And here, you might not have the same number of buttons, and the buttons will have different names, but that's it. I mean, you could even do that. Heck, you could even do that for SimStation, I guess. SimStation, I guess, yeah, I think it just has those buttons on it. So it should be, again, if like you've got an MVC that works, you can pretty much do this thing. You can pretty much do this application at home without knowing what the application's about. Just call it midterm. Okay, how are we doing here? All right, let's go back to the review. How am I doing? Not very well. Let's do a new share. I gotta like kind of pick up the pace here. Okay, we're back to the midterm review. Here's another problem I like. So Casino Royale, that's similar to homework assignment 3, turtle graphics, MVC customization. Problem 4 is similar to homework number 2. This is a state machine. And then problems 2 and 3 are similar to homework assignment number 1. So I like those. You know, I think that's probably too many problems for the midterm, but you know, I like those because you get homework similar to it. Let's look at state machine. State machine is a current and final state and a program. Current and final states are of type S, where S is a type parameter, okay, so generic. Program is a list of commands. I'm thinking here of polymorphism. Probably it's going to be a polymorphism. State machine execute a program by sequentially executing the program's commands. So I'm thinking stack machine, very similar to that. It ends when the end of the program is reached or earlier if the current state becomes the final state. And then when executed, a command computes a new state from a current state. It may also throw an exception. So this has all of those object-oriented elements to it. And then I give you a test harness. So it's always good to look at the test harness because that helps you understand the program a little bit. So here we see I've created a bunch of different kinds of commands. Here is a mod command. It implements command of integer. So I guess there's going to be a command class. And here is execute. It takes an integer as an input and returns s mod some modulus. The modulus is 2 here. Okay, so similar with these others. And then here's the main method. Here it's creating a state machine SM, which is a new state machine. The state space is integers. The start state is 2. And the halt state is 10. Which maybe you wouldn't be able to tell that from looking at the code. And then here I'm adding a bunch of commands to the state machine, and then I'm executing the state machine. I think. Okay, so, and then the problem is to implement it. And here I've given you my solution. So again, command. So here this is borrowing ideas from the commands as objects, a command processor pattern. So a command knows how to execute its stuff. It takes, notice that this is generic interface. So that's kind of trippy. State is, you know, the input and output types of execute. I don't want to say what they are yet, so I've just made it a parameter. Execute takes the current state as an input and returns like the next state. And it might throw an exception. Okay, so if you go back and look at those different commands I created, you'll see they all implement this interface. Here's the state machine itself. Okay, it's a generic class. So I'm getting you on that. Okay, it's got these 2 states, current state and halt state. They get initialized here. And then here is execute down here. And this is, again, an example of that polymorphic programming. I'm going to iterate through all of the commands in the program, and I just execute each command. I give it the current state as an input, and I set the current state to be whatever the output. So each command, when it gets executed, you know, change is telling you what the new current state should be. Okay, if the current state is ever equal to the halt state, I use break here to break out of this loop. So you should know about break and continue for this. Okay, so, and then this is this spreadsheet. Let's look at the design for the spreadsheets. You might have to reload the midterm review because I just fixed this link. So a spreadsheet has a bunch of cells in it. Oh, you know, shoot, okay, I forgot about this. So this problem is an older problem, and it used Java's observer observable. That's how Java originally did publisher subscriber. And this is like observable as publisher and observer as subscriber. And this is cool because each cell in a cell sheet is both an observer, a publisher, and a subscriber. I think we're going to have to like axe this problem because we observe and observable are now deprecated in Java. So that's why I switched to Beans. So maybe that's not a good example. Here, problem 2 and 3, you're converting text into class diagrams. So I'll do one of these things for you and post the solution. Okay, let me, I'm kind of running out of time here. Get my chat back up. Okay, so any questions? Okay, well, I'm going to have an office hour in about 15 minutes. If you want to come in and talk about projects or the midterm. And let's see, there's going to be one MVC question for sure, right? I didn't say for sure. Maybe there'll be an MVC question. Probably there'll be an MVC question, but nothing's for sure in life. We have office hours at later times. Let's see. I wasn't planning on any other office hours. You know, I think maybe if you have questions, why don't you do it through email? I'll have an office hour Thursday, but after the exam. Yeah, Aisha, I did get your email about that, and I will. I'll answer it. I'll answer it later today. I'll add upload problem 2. I'll upload a solution for problem 2. I don't know if I'll get to 3. Probably be a class again. I don't want to like say probably. I mean, you can. I'm being asked if there will be probably privately. You can ask these questions publicly. I'm asked if there will probably be a class diagram question. Okay, let me answer that. The probability the class diagram, there'll be a class diagram question is 0.3 out of 1. Anything else? Okay, I am going to bounce out of this now, and I'll see you during office hours.